Chapter 6 Rotorcraft Flight Manual Introduction. An essential component of flight instruction is ensuring the student becomes familiar with publications that provide information required for flight. One of those publications, the Rotorcraft Flight Manual, RFM, not only contains information critical to safe flight, it is also required to be carried in the aircraft. Introduce students to this manual and the material it contains at the beginning of the training program. Figure 6.1. Introducing the manual. When introducing the manual for a particular helicopter, a good place to begin is the certification basis of the helicopter as defined by Title 14 of the Code of Federal Regulations, 14 CFR, Part 27, Airworthiness Standards, Normal Category Rotorcraft, or Part 29, Airworthiness Standards, Transport Category Rotorcraft. The certification establishes the framework for development of the helicopter itself as well as the performance requirements for that certification level. Another method for introducing the RFM to a student is to review the manual section by section. Discuss the information contained in each section and why that information is important to a pilot. Explain that some manufacturers use the title Pilot's Operating Handbook, POH. If PO is used, the title page must include a statement to the effect that the document is a Federal Aviation Administration, FAA, approved RFM. Emphasis must be placed on the fact that no two RFMs are exactly alike. Explain to the student that although the manual format is standardized for the make and model of an aircraft, some of the information contained therein relates to a specific aircraft. The title page indicates the registration number and serial number of the aircraft to which the manual applies. Ensure the student understands that an aftermarket PO does not meet the requirements of the RFM. Another piece of information to include would be the subject of supplements to the RFM. Students need to be advised of the need for RFM supplements when equipment not included in the Type Certificate Data Sheet, TCDS, is installed into the aircraft. The supplement often changes procedures and limitations stated in the RFM, and would be more restrictive than the more general factory information. The TCDS is a formal description of the aircraft, engine, or propeller. It lists limitations and information required for type certification, including airspeed limits, weight limits, thrust limitations, etc. Assist the student in finding the TCDS on the FAA website and show the student the basis for the building of that helicopter and where the limitations are stated. Figure 6.2, Sections of the Manual. General Information. Section 1, the General Information section provides basic descriptive information on the helicopter and the power plant and is a good place for the instructor to familiarize the student with the aircraft being flown. Since this section provides the basic dimensions of the aircraft, examples of how the student might use the information can be incorporated into the lesson plan. Discussion of the aircraft's overall dimensions can be used to calculate hangar area required. The diameter of the rotor disc can be used to determine the altitude of aircraft for ground effect. The dimensions of the helicopter primarily define the amount of space needed for the helicopter's landing and takeoff areas. For example, the hover pad should be the main rotor diameter plus the tail rotor's diameter and some margin for maneuvering error and enough distance to be able to clear obstructions during takeoff and landings. Review the takeoff and landing charts with the student so they have a better understanding of the distances involved. Review the aerodynamics so the student remembers why vertical takeoffs and landings, even if possible, are not advised, and probably are not the safest maneuvers usable. The instructor should teach the student that for Part 27 helicopters, the charts are advisory. Whereas, the charts for a Part 29 helicopter may be limiting depending on the verbiage in the limitations section of the RFM. However, should an accident occur, operating outside given acceptable parameters may be grounds for a careless and reckless determination. Operating limitations. Section 2. This section contains those limitations necessary for the safe operation of the aircraft and should be thoroughly reviewed with the student. Divide this section into subsections for discussion purposes: instrument markings, operating limits, loading limits, and flight limitations. Explain each one to the student. Show the student how the information related to instrument markings is depicted on the instruments in the aircraft. Make the information relevant by explaining the markings and how exceeding the limits affects flight. Show the student the flight limitations section and discuss how the limitations relate to safe flight. Review the weight and loading distribution section, emphasizing the information concerning maximum certificated weights, as well as the center of gravity, CG range. Point out any prohibited maneuvers or restrictions to flight. Do not assume a student knows what a placard is, show an actual placard on the aircraft. Always relate what is written in the RFM to what and where it is on the actual aircraft. First, identify the tachometer and explain the markings. Then, point out which needle indicates engine revolutions per minute, RPM, on which scale and where to read the rotor RPM. Figure 6.3, The student should be well aware of the importance of maintaining rotor RPM at all costs. For example, in dealing with emergency procedures not necessarily documented in the RFM, if the rotor tachometer fails in flight, maintaining powered flight and monitoring the engine tachometer should keep the rotor within the limitations. However, this should never be used to allow takeoff with an inoperative main rotor tachometer. The student should appreciate that if the rotor is in the low green range, then the glide distance will be somewhat farther, but too little. Rotor RPM allows the blades to fold or bend upward in flight with no chance of recovery, or little to no cushioning energy during the touchdown phase of an auto-rotation. Excessively high main rotor RPM can overstress the blade retention parts, leading to immediate blade loss or begin stresses which lead to blade loss in the future. Emergency procedures, Section 3, remind the student that while flight is generally safe, it does include an element of risk. One of the risks associated with flight is equipment malfunction or failure. These include engine, tail rotor, or system failure, or fire. Explain that the manufacturer has developed procedures for coping with emergencies and includes those procedures in this section. Figure 6.4, Accidents and Helicopter Operating History proves that training in emergency procedures in helicopters is beneficial, although sometimes expensive. Experience indicates that helicopter training is much more demanding than airplane training due to the differences in the machines and failure modes. However, with the proper training, helicopter flight can as safe as airplane flight. Although the FAA does not encourage memory items for checklist procedures, due to the complexity and aerodynamics of the helicopter pilot must be better trained, more attentive, and more responsive than the average airplane pilot. In many situations, the helicopter pilot must react almost instantly and accomplish the necessary items without the aid of a checklist, since the emergency may end before a checklist can be located, read, and followed. For example, helicopters commonly fly at an altitude of approximately 1,000 above ground level, AGL. If an engine or driveline component fails at this altitude, the time remaining aloft is only about 44 seconds for common 4 or 5 place reciprocating engine-powered helicopters with a power-off descent rate of 1,350 feet per minute, FPM. Remind the student that, in those 44 seconds, or less with the entry into auto-rotation, the pilot must, 1. Achieve auto-rotation airspeed, 2. Control the rotor RPM, 3. Confirm the wind direction on the surface, 4. Find a suitable landing area, 5. Maneuver into the suitable landing area while missing any obstructions, for example, wires, fences, trees, and towers, 6. Identify the actual landing spot during a low, quick, reconnaissance, and then 7. Complete the auto-rotative landing while A. Thinking about a mayday call, and B. Accomplishing checklist cleanup items, for example, fuel valve closure, battery switch to off, and activation of the ELT. All of these tasks must be accomplished while using both hands to fly and keeping the aircraft in trim with the pedals. Imagine the helicopter descending faster than the power-off descent rate of 1,350 fpm, and that most helicopter pilots train an aircraft much lighter than gross weight. In the rare event something fails, that emergency landing may be the pilot's first at that weight. Using the RFM, show the student how the manufacturer distinguishes the emergency procedures section and makes it easy to find. Review the various types of emergencies included in the RFM and the manufacturer's recommended procedures. Explain that manufacturers identify the immediate actions that aid the pilot in maintaining aircraft control when coping with an emergency. These actions must be completed instinctively, without reference to a checklist. If the situation permits, immediate action should always be followed by completing the full emergency checklist to ensure all items have been covered. More in-depth discussion of helicopter emergencies can be found in the Helicopter Flying Handbook, Chapter 12, Helicopter Emergencies. Emphasize to the student that procedures in the RFM take precedence when there are differences between the RFM and other publications regarding pilot actions. Normal Procedures, Section 4, a student should understand that the Normal Procedures section of the RFM is used more than any other section since it includes checklists for all phases of the flight from the pre-flight inspection of the aircraft to the post-flight inspection. Explain to the student how proper use of a checklist ensures manufacturer's procedures are followed. Demonstrate the proper use of the checklist for pre-flight, engine start through shutdown, and post-flight. Remember, an instructor serves as an important role model for the student. Never complete a checklist from memory. Reviewing accidents in which checklist items were missed is a good technique to help the student understand the importance of checklists in day-to-day helicopter operations. More information concerning normal flight operations and procedures can be found in Chapter 9, Basic Flight Maneuvers, and Chapter 10, Advanced Flight Maneuvers, as well as the Helicopter Flying Handbook. Performance, Section 5, The performance section contains all the information required by the regulations and any additional performance information the manufacturer determines may enhance a pilot's ability to operate the helicopter safely. When discussing this section, emphasize the importance of the correct use of charts and pre-flight planning to determine fuel consumption or power or torque available for the given flight conditions. Explain the differences between the in-ground effect, IGE, and out-of-ground effect, OGE, hover charts. The most important function of discussing OGE versus EGE hover charts is the possible performance restrictions. If the helicopter cannot meet OGE requirements. In those instances, instructors should show the student how to plan approaches more carefully and maneuver the helicopter to maintain ETL at all times. The instructor should ensure the student understands the performance limitations, even if the information is advisory and not regulatory limiting. Ensure the student understands how to read the height/velocity diagram and the importance of the information obtained from the chart, as well as how not to fly in the avoid areas of the chart unless the flight task specifically demands that profile. Again, make the use of the charts meaningful by giving examples of how the information contained in this section is used in determining the parameters of a flight. For example, if the student plans the flight using the highest temperature forecast and the highest altitude expected, then a practical expectation of the helicopter's performance can be derived. If EGE hover is not possible by the charts, then the loss of translational lift will probably result in a landing, desired or not. Always plan to hover EGE. If EGE hover is not possible according to the charts, is the flight really necessary at that weight? The student should remember that a helicopter needs power to stop, come to a hover, and take off to clear obstructions. Maybe less fuel can be carried, or more than one trip can be flown to move the people or weight in a safe manner. Direct the student to the Helicopter Flying Handbook, Chapter 8, Helicopter Performance. Weight and Balance, Section 6. The Weight and Balance section should contain all the information required by the FAA to calculate weight and balance. Explain to the student the importance of determining the weight and balance of the aircraft for each flight. Weight balance is very important to a helicopter with its limited CG range. More important than the structural maximum gross weight may be the maximum gross weight for the altitude and temperature. Since the helicopter uses almost maximum power for hovering, the loss of power due to thinner air at higher altitudes and temperatures can be especially critical to helicopter operations above cool sea level points. Show the student how the information provided in this section is used to make weight and balance calculations. Make the information relevant by demonstrating how to complete a weight and balance computation for a training flight. Refer the student to the Helicopter Flying Handbook, Chapter 7, Weight and Balance, or the Pilot's Handbook of Aeronautical Knowledge, Chapter 9, Weight and Balance, for more information regarding weight and balance. Aircraft and Systems Description, Section 7, the Helicopter Flying Handbook, Chapter 5, Helicopter Components, Sections, and Systems, contains a general description of the various systems found on a helicopter. Explain to the student that this section of the RFM contains a specific description of the systems on the aircraft. Emphasize that a good pilot becomes familiar with the systems on the aircraft because detailed knowledge of the systems of an aircraft is essential for determining whether flight is advisable. Explain to the student the best way to become familiar with the systems is to study the information in this section. Handling, Servicing, and Maintenance, Section 8, the Handling, Servicing, and Maintenance section describes the maintenance and inspections recommended by the manufacturer, as well as those required by the regulations, and Airworthiness Directive, AD, compliance procedures. Explain that an AD is a notification to owners and operators of certificated aircraft that a known safety deficiency with a particular model of aircraft, engine, avionics, or other system exists and must be corrected. If a certificated aircraft has outstanding ADs with which the operator has not complied, the aircraft is not considered airworthy. Thus, it is mandatory for an aircraft operator to comply with an AD. ADs usually result from service difficulty reported by operators or from the results of aircraft accident investigations. They are issued either by the National Civil Aviation Authority of the country of aircraft manufacture or of aircraft registration. When ADs are issued by the country of registration, they are almost always coordinated with the Civil Aviation Authority of the country of manufacture to ensure that conflicting ADs are not issued. In detail, the purpose in AD is to notify aircraft owners that the aircraft may have an unsafe condition, or the aircraft may not be in conformity with its basis of certification or of other conditions that affect the aircraft's airworthiness, or there are mandatory actions that must be carried out to ensure continued safe operation, or, in some urgent cases, the aircraft must not be flown until a corrective action plan is designed and carried out. ADs are mandatory in most jurisdictions and often contain dates or number of additional aircraft flying hours by which compliance must be completed. ADs may be divided into two categories: those of an emergency nature requiring immediate compliance prior to further flight, and those of a less urgent nature requiring compliance within a specified period of time. The student should know where the AD compliance record is located in the maintenance logs of the helicopter and the proper way to check it. Owner/operators of an aircraft must now request to receive ADs electronically, as the ADs are no longer mailed to owners of record. However, the owner/operators are still responsible for AD compliance. Acquaint the student with how this section outlines the service, maintenance, and inspection intervals for the different components of the aircraft. Point out that it also establishes time between overhaul, TBO, limits for components, such as rotor blades and gearboxes. Explain to the student that this section also describes the preventive maintenance required, as well as ground handling and storage procedures. The pilot should always know what type and brand of oils are being used. The RFM may specify what is acceptable, but it is best to not mix brands in engines and transmissions/gearboxes. Supplements, Section 9. When acquainting the student with the supplements section, explain that this section provides pertinent information necessary for the installation and operational considerations of optional equipment, such as floats or spray equipment. Figure 6.5. Stress that the information may be provided by the aircraft manufacturer or the optional equipment manufacturer, and that in either case, it becomes part of the RFM when the equipment is installed. Other important information located in the supplements section includes any changes required in the normal, abnormal, and emergency checklists, and servicing, pre-flight or maintenance requirements. Additions or supplements should always be placed in the supplements section of the flight manual so that the owner/operator maintains all additions and changes in one place rather than creating alternate checklists that could cause important information to be misplaced or forgotten. Instructor tips. Much of the information in this chapter lends itself to oral assessment of fact questions, discussed in Chapter 5, Assessment, from the Aviation Instructor's Handbook, based on memory or recall. To engage the interest of the student, make the information as relevant as possible to the flying experience. Figure 6.6. Chapter Summary. This chapter provided discussion points for the instructor to help the student learn the important limitations stated in the RFM. It also explained how to assist the student in understanding the importance of pre-flight planning in regard to safe flights, as well as recognizing the critical steps in the published emergency procedures. The applicable 14 CFR regulations were discussed, and how the relationships integrate to satisfy safety regulations and safe flight practices.